So the first thing I want you to think about is how we started off yesterday with absolute value equations. I said, hey, give me a number that would give me an actual exact absolute value that I could put in for x that's equal to 3. And you said, well, the x could equal a positive 3 or x could equal a negative 3, right? And we're going to do something similar to that today with our inequalities, except there's going to be one little trick that goes along with it. Today, I'm going to say, give me a number that has an absolute value that's less than 3. So that right away requires you to do a little bit more thinking. It makes you think, if I put 2 in there, would that work? Is the absolute value of 2, which is 2, less than 3? Yep. 1 would work. 0 would work. Any negative number would work, right? Okay? So, actually, no, I'm not saying that any negative number would work. That's what I'm going to show you next. So, if I were to say, well, watch. Let's talk about that. Would negative 1 work? Yes. Would negative 2 work? Would negative 3 work? No. Would negative 4 work? No. So, how can I show, because here's what you guys are thinking. If you go based off what I told you yesterday, you're going to have one answer right every time. So if I say, hey, the absolute value of x is less than 3, and you think, oh, so then x could be less than 3, and for that second equation, x could be less than negative 3, you're going to be part right. Okay? Because if you think this and you think this, you knew right away that some negative numbers will work, but once you get to a certain one, they stop working. Why do they stop working? Because the actual number itself might be less than 3, but the absolute value of it may not. So if I were to pick a number that is less than negative 3, like say negative 4, and put negative 4 in there, watch what's going to happen. You already caught it, right? The absolute value of negative 4 is positive 4, and positive 4 is not less than 3. So what could I do to this little problem right here to make it true? Yes. Switch the sign. Oh, you mean that if I just took this sign right here and switched it, then it would be true? Yes. So here's the deal with inequalities. You're always switching them and flipping them somehow, right? Okay? You will be a master at this lesson if you know when to flip it. Okay? So let me show you what you're actually going to write when you're given this problem. You told me that for your 2 equations, which you're still going to have today, that the first one is basically what you're looking at. In order for this to work, x has to be less than a positive 3 or greater than a negative 3, right? It has to be less than a positive or greater than a negative. So I want you to just kind of look. The first one is what you thought, and hey, the second one is kind of what you thought. You have one positive and one negative, but now you have to flip the sign. So here's the really cool part about today. I spent a really long time yesterday teaching you about clearing it out and multiplying by this and divide by that. I don't need to do all that again. All I need to do today is say, hey guys, everything you did yesterday, do it again today, except for that second equation, in addition to making it negative, don't forget to flip that sign. Okay? Let me show you what I mean by that. So if I were to do this problem, x minus 5, the absolute value of x minus 5 is greater than or equal to 7. Is there anything in front to divide by? No. Behind to add or subtract? No. Let's go right into our 2 equations. And the first one is going to be exactly as it appears. So in other words, the absolute value of x minus 5 means x minus 5 could be greater than or equal to a positive, or x minus 5 could be less than or equal to a negative. And if you can remember to do that with a few other twists that I'm going to show you in a minute, you will be just fine. So yesterday, after we talked about solving absolute value equations, I had an overwhelming amount of kids say, this is so easy. This is way easier than solving multi-step inequalities. Can we take the test tomorrow? And I was like, awesome, they're really getting it. This is kind of the same thing with one extra little twist there, okay? So let's talk about a problem like this. Let's say 5 minus x divided by negative 3 plus 2 is less than or equal to 6. I'm like, hey, let's just jump right into it, right? So as I'm looking at this problem, do I see any addition or subtraction that I have to clear out? Yep. Order of operations backwards. Get rid of this 2 first from both sides. What's left on the left? The absolute value of 5 minus x here over negative 3. Still less than or equal to 4. By the way, I had a couple kids flip on 2, 3, flip this, and they said, well, you have a negative, you did something to both sides with a negative. Yeah, I subtracted, but I didn't multiply or divide. Remember, it's only multiplying and dividing. So now what do you think I do next? What's in the absolute value and what's not? Yeah. Right, the negative 3 is not. So it's not protected right now. You can't do anything with it, whatever's inside, until everything's gone. If I multiply this side by 3, I multiply that side by 3. Now, time out. You have to remember from 2, 3, what am I doing? I'm multiplying by a negative. What kind of problem is it? An inequality. So what I'm about to do is rewrite this like that. Do you see that? Anywhere in any inequality problem, when you multiply or divide by a negative like that, you have got to flip the sign, okay? Then, this works out to be I'm done. I am done with this problem. Why? Yeah. So do you remember from yesterday? There's no number that I can come up with that gives me an absolute value that could be greater than or less than or equal to a negative number. I'm done. Don't make the mistake of going 5 minus x is greater than or equal to a negative 12. 5 minus x is less than or equal to a positive 12. Don't do that. If that's a negative, you are done. But don't just write done. Don't write no answers. Write no solution. Okay? Do you understand why that's no solution? So I'm done with that. Okay? All right. I want to show you the difference between what to do, like this one here. It was in, let's talk about the difference of this problem. And this problem. Boy, they look awfully similar, don't they? What's different about them?
The absolute value is only around the x.
Right. So we just did a problem like this, right? Where the bottom wasn't in there. So I know, you would subtract 6 from both sides. You would get the absolute value of x over 3 is greater than 9, and then you would multiply both sides by 3, right? Just like we did a minute ago. Then you would get, be careful, the absolute value still of x is greater than, and because I didn't multiply by a negative, I don't need to switch it, right? Does everybody understand why I did not change it? And now, when I get to this, what are all the values that x can be? Oh, you could pick any number that you want as long as it's greater than 27, or what? Less than negative 27. So if I go back to saying, make sure you have one greater than the positive, one the opposite of the negative. Whatever this sign was, make this sign the opposite. You with me? So then that brings up a good point. How would I solve this one up here then? What would I do? Would I still subtract the 6 first? Yeah, that part doesn't change. That's going to give me x over 3 is greater than 9, and now what do I do? Is everything cleared out? Now I go into my 2 equations. One of them being x over 3 could be greater than a positive 9. What's the other one? X over 3 could be less than a negative 9. Are you seeing this? It is literally the same exact lesson as yesterday. I'm not done. I got to finish it. But now all I do is I just multiply both sides by 3. Here, x is greater than 27. Multiply both sides by 3. Here, x is less than negative 27. Okay? Although it worked out to be the same. All right. So now let's take a look at this problem here. All right, ready? Done? Got it copied? Okay. 6 plus the absolute value of negative 3x plus 1 is greater than 10. All right. There's a plus there. Good, because if it was a minus, I would have to do the divided by negative 1. So first I'm going to get rid of this. I want to clear up a misconception that some kids are having. And so this says negative 3x plus 1 is, I just subtracted, so I don't need to switch it. So I have a lot of kids when they're working with inequalities think that anything inside the inequality sign that's a negative has to become positive. And that's not true, because I'll show you why in a second. This is what you're going to write. Greater than a positive 4. Negative 3x plus 1 is less than a negative 4. Somebody said, why didn't you take the absolute value of that? A couple people. And so I want you to think about when there's an expression like this. Let's just do this. If they're in separate or absolute value signs, that means take the absolute value of that term and take the absolute value of this term and add them, right? If they are together, they are part of an expression, you have to treat it like it's that expression. So I'm not going to take the absolute value of it. I'm going to do negative 3 plus 1, which is negative 2. And now take the absolute value of that sum, right? So when it's a term by itself, yeah, it's got to come out and be negative. But when it's part of that expression, it remains what it is for right now. Yeah? Yes, go ahead. So then we were going to finish solving this. Subtract 1. Negative 3x is greater than 3. And look what I am doing. What am I about to do? Because I just divided by a negative. These are going to slip out of your attention very easily. Don't let them. This whole lesson, it may as well say at the top of the learning target, I know when to flip the inequality sign and when not to. And that's really all that this lesson boils down to. Because I know you know how to solve equations by now. A lot of us took care of that with 2, 3, and 2, 4, or 2, 2, and 2, 3. It's all about catching your signs. Negative 3x is less than negative 5, and don't flip it till you do it. I'm having some people flipping it right in that step. I just subtracted 1. I didn't flip anything. Now you flip the sign, and x becomes greater than positive 5/3. Okay? Is this good? Making some sense? All right. So then, let's look at one like this. Negative 4 times just the a. All right. What should I do first? Anything on the outside? Yep. So what do? Divide by a negative. And I just divided by a negative. So I should do what? Take that and make it greater than. And what's 0 divided by anything? 0. Does that mean stop and red flags go off and you say no solution? No, it does not. It means 0 is 0. Well, I need to make like a little poster with like a 0 is 0. That's like he's a number 2. He's important, right? It just means, yeah, 0 lives matter. Yeah, it just means what? I'm only going to have one answer, right? Because, actually, I'm sorry, change that. I was about to say you're not going to have one answer. Why are you not going to have only one answer in this? Because why? You can't make a negative 0, but you can do what? Flip the sign. So your answer is A is greater than or equal to 0. A is less than or equal to 0. That's a weird one to try to wrap your head around. So I know that you can't flip the sign. Or I know that you can't make 0 negative, but you can still do at least one of the two things you're supposed to do, right? So, inequalities, when that's 0, it doesn't mean you're only going to have one answer. It means that in an equation, right? Just not in an inequality. Okay. Good so far on solving these? It's all about flipping. So I got like 2 more things to show you. So I might ask you to solve an equation, and I might ask you to say negative 8 x, let's see this. 8 minus x plus 15 is less than or equal to 20. Okay? And then I might say, is 0 a solution to this inequality? So all I'm looking for is a yes or no yes or no answer, okay? So if I were to say solve this, and does 0 fit in with what you're telling me, let's go back to look at some of the problems that we did. Some of the answers that we did said, hey, x can either be less than 3 or greater than negative 3. Let's talk about what that looks like on a graph. Ready? Here's negative 3. Here's positive 3. Pretend like that's not there, guys. Show me on this number line what means greater than negative 3. An open circle going that way, right? Where on this graph means x is less than 3. An open circle going this way, right? And so, are there some numbers that fit both of those? Yeah. Are there some numbers that are less than positive 3 but also greater than negative 3? Yeah. What are they? Negative 2, negative 1, 0, 1, and 2. Right? So, what's that? Oh, you're just saying it. Yes. So, those are the numbers that fit both. Okay? So, let me explain to you something. Last year, there were 40 learning targets in algebra. This year, there's 38. I took out compound inequalities. I want to talk to you real quick about what compound inequality is. Compound inequality says when you go to check your answers today, they're going to be written like this. And you're going to look at that, I guarantee you, and you're going to go, what does that mean? Because that's not what I have on my paper. Okay, so let's talk about that. To talk about that, let's go back to first grade when you learned about a compound word. What's a compound word? Remember those? Mm-hmm.
It's two words put together like household.
Yes, it's two words that are words by themselves, but when you put them together, it means another thing. Chalk and board means chalkboard. School bus. Firehouse, right? So then, that's a compound word. So a compound sentence is what first graders are in desperate need of, because every time they have to write something, I like tacos. I like pizza. I like cats. I like dogs. And a first grade teacher's job is to say, hey, let's make a compound sentence out of these. And how do you do that? How do you make a compound sentence? Yeah, I like tacos and pizza, right? So we know what a compound word is. We know what a compound sentence is. This is a compound inequality. It's where I just combine some things. So this is not something you're going to be tested on. It's not something that you absolutely have to know, but the answer keys will be in this form, and I need you to know whether you did that or not. So a compound inequality means I took two separate inequalities and made them into one. Let's cover that up. You're looking at one of them. One of the inequalities that I took was m is less than 3. Then I'm going to cover this up. What's the other inequality that I'm looking at? M is greater than negative 3. Remember, because the nose knows, right? Remember that? Put the little nose on the thing, and if you got to move some things around, that nose has to still be there, right? So you are probably going to have this on your answer page, but that's what's going to be in the book, and I need you to know that this and this is the same thing. You do not have to put your answers like that. You can leave them separate, but when you get that, understand what that means, Joel.
It looks hard, but that's easier than half the stuff we've already done.
Yeah, it's just looking at it. And here's another thing why it's easy. Think about this. The letter M on this paper is physically what? In between negative 3 and positive 3, right? Yeah. Yes. So with it being right in between then, what they're doing is they're talking about all the numbers that are in between those two numbers, which are negative 2, negative 1, and so on. So I'm going to give you one, and I want you to tell me all the numbers that fit the solution. So this is how you read it. 8 is less than or equal to x, which is less than 12. That's how you read a compound inequality. 8 is less than or equal to x, which is less than 12. How many numbers am I talking about? If I had to give out $100 for every person who was able to give me a number that fits in that solution set, how much would I need? I had to count that. Chris? One more. I would need how much? 400. Did you count 8? Yep. That's why I put one of them has a line under it, one of them doesn't. Okay, so give me a number less than 12. 11, 10, 9. Don't stop there, though, because it also has to be greater than or equal to 8. So that's where that fourth number comes in. So this solution set could include the numbers 8, 9, 10, and 11, and nothing else. Okay? So just know that when you see it written like that, what it means. Okay? So back to this. If I were to say solve this inequality, and then is 0 a solution? Is 0 a solution here? No. So basically, you have to just solve it and tell me whether that is or not. Okay, so here's what you're looking for today when I pass out the assignment. Watch when you flip the signs. You might have to flip it one way while you're clearing things out, and then in your 1-2 equations, flip it again. Yes, Joel?
Can we work it harder?
Yeah.